Hello students, welcome back to my video lectures on chemical bonding and molecular structure. As we know, we are solving multiple choice questions from previous two videos. So we will continue with the same process. Yes, so I think we finished first question, second, third, fourth, fifth we have not finished because I've told you we'll do it at the end. Yes, 6th completed, 7th completed, 8th is finished, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th is also done, 17th, and I think the last question was 18th question. And what was the answer for this question? It is B, which decreases. So now we'll go with the next question. Which of the following has highest lattice energy? Which of the following has highest lattice energy? So lattice energy is like this. See for example, students, we know Farjan's rule, isn't it? Farjan's rule. According to Farjan's rule, smaller the size of cation, smaller the size of cation and larger the size of anion, larger the size of anion, more will be the covalent character, isn't it? More is the covalent character. Yes, more is the covalent character. Let us just change the chalk piece. Sir, can I get the chalk piece? More will be the covalent character. Smaller the size of cation and larger the size of anion, more is the covalent character. If I reverse this situation, that is larger the size of cation, larger the size of cation and smaller the size of anion, smaller the size of anion, more will be the ionic character. More will be what? Ionic character. More will be the ionic character. More the ionic character. More the ionic character. More will be the ionic character. More the ionic character, more will be the lattice energy. More will be what? Lattice energy. Please note this point. Note this point. Very simple question. Are you able to understand? I want you to remember this rule. What is that rule? Larger the size of cation, and smaller the size of anion, more will be the ionic character, and more is the lattice energy. More is the lattice energy. Are you able to understand? Larger the size of cation, smaller the size of anion, more will be the covalent character and more is the lattice energy. Our question is about highest lattice energy. So if I want to judge which has highest lattice energy, I should just check which one has highest ionic character. If I have to judge which has highest ionic character, then I have to see which cation has large size and which anion has small size. Which anion has small size. Yes. Now, I'll take the compounds that are given. Yes. Which are the compounds that are given? We have lithium chloride, sodium chloride, potassium chloride and magnesium oxide. I'll tell you why I wrote it like this. Yes, we have lithium chloride, sodium chloride, potassium chloride and magnesium oxide. We know lithium chloride is formed from what? Lithium ion and chloride ion. Sodium chloride is formed from sodium ion and chloride ion. Potassium chloride is formed from potassium ions and chloride ions. Here, and magnesium oxide is formed from magnesium ion and oxide ion. Yes, students, Students, we know that, okay, down the group, ionic size increases. Here, anion is the same, chloride, chloride and chloride. Anion is the size, but as we go down the group, ionic size increases. As the ionic size increases, that means potassium ion is bigger. Potassium ion is bigger. Okay, yes. So, higher the size of cation, smaller the size of anion. Okay, more will be what? Covalent character. More will be the ionic character. More the ionic character, more is the lattice energy. Hence, lattice energy is highest for what? Potassium chloride. Okay, because as we go down the group, yes, okay, now size increases, ionic size increases. That means potassium ion is bigger than sodium ion. Sodium ion is bigger than lithium ion. So as the size increases, higher the positive charge, that means larger the size of cation, smaller the size of anion, more will be the covalent character. More the covalent character, more is the lattice energy. Hence the lattice energy is maximum for, the lattice energy is maximum for what? Potassium chloride. Okay, is that simple? Okay. Yes. Next question, students. Okay. Next question. Okay. Which of the following does not have a coordinate bond? Okay. Which of the following does not have a coordinate bond? So students, it is it has to be NH4 plus, okay, CO3 2 minus, H3O plus and O3. I have told you what is coordinate bond. Do you know what is a coordinate bond? Okay, yes. What is a coordinate bond? Yes. Okay. See, we know covalent bond. What is a covalent bond? Okay. Yes. It's a bond formed by mutual sharing of electrons, isn't it? A bond formed by mutual sharing of electrons. Mutual sharing of electrons, isn't it? So if I consider hydrogen molecule, okay, one hydrogen will share one electron, the other hydrogen will share one electron. So here both the hydrogen atoms are sharing the electrons. Okay, so a bond is formed, and what do you call that bond? As covalent bond. If I consider a covalent bond, this is a bond formed by sharing of electrons by one of the combining atoms. That is called as coordinate. Here both the combining atoms will share the electrons. That is called as covalent bond. Here, okay, in coordinate bond, only one of the combining atoms will share the electrons. The other will not share. Only one of the combining atoms will share the electrons. Well, we call that type of bond as what? Coordinate bond. Okay. If only one of the atom shares the electrons, that is called as coordinate bond. If both the combining atom shares the electrons, then it is called as covalent bond. Okay. Yes. For example, if I consider ammonium ion. See how ammonium ion is formed. Option A. How ammonium ion is formed. Okay. We know nitrogen has, okay, lone pair of electrons, isn't it? And okay, it combines with what? H plus. H plus 1 as 0. Okay, hydrogen has vacant orbital. So nitrogen will share this lone pair of electrons with hydrogen. Nitrogen will share, okay, the lone pair of electrons with hydrogen. Hydrogen will not share the electrons. Only the nitrogen will share the electrons. Therefore, there is a bond formation between nitrogen and hydrogen, and we call that bond as coordinate bond, and we write that coordinate bond by an arrow mark, just like this. just like this. So there is a coordinate bond between nitrogen and hydrogen. Nitrogen is completely sharing the lone pair of electrons to hydrogen. Now hydrogen is not sharing any electrons. So what is this bond called as? This bond is called as coordinate bond. Next, if I take carbonate, CO3 2 minus, option B, carbonate, CO3 2 minus. Carbonate is something like this. Look here, carbonate, C double bond O. Okay, yes. Do you know the formula of carbonate? Yeah, okay. No, yes, O minus, and the other one is O minus, CO3 2 minus. Here, carbon will share the, no, sorry, okay, oxygen will share the electrons to what? Carbon. Oxygen will share the electrons to carbon. So there is no, carbon will not share the electrons. Only oxygen will share the electrons to carbon. So this bond is formed, or else, okay, carbon will share the electrons to oxygen. When carbon shares the electrons to oxygen, oxygen will get negative charge, isn't it? Okay. So here, oxygen is not going to share the electrons. Only if the carbon is going to share the electrons. So what is the bond formed between carbon and oxygen? It is a coordinate bond. Coordinate bond. Next, if I consider water molecule, option C, hydronium ion, H3O plus. Okay. How is hydronium ion formed? Look at here. Yes. How is hydronium ion formed? Hydronium ion. Okay. H3O plus. So we know water molecule, H2O, isn't it? H2O. Oxygen has lone pair of electrons. Well, okay. So oxygen will share the lone pair of electrons with H plus. Okay, hydrogen will not share the electrons. Only oxygen will share the electrons. So there is a bond formation. And what is that bond form called as? Yes, it is, okay, coordinate bond. And how do you indicate that coordinate bond? With an arrow mark. With an arrow mark. That means we can observe coordinate bond in ammonium ion. We can observe coordinate bond in carbonate. We can observe coordinate bond in hydronium ion. But we don't have coordinate bond in ozone. Ozone, it's just simply like this. All the bonds are covalent bond. No bond is coordinate. This is a covalent bond. This is a covalent bond. This is also covalent bond. None of them are coordinate bonds. None of them are coordinate bonds. Hence, the correct answer for this is option D. Which of the following does not have coordinate bond? It is ozone. Ozone, O3. Not, okay, yes. Ozone is the correct answer, which do not have covalent bond. Okay, yes, that's great. Yes, students, next question. Okay, ether is more volatile than alcohol, having the same molecular formula. Okay, ether is more volatile than alcohol, having the same molecular formula. This is due to dipole character of ethers. Alcohols have resonating structures, intermolecular hydrogen bonding, okay, in ethers, or intermolecular hydrogen bonding in alcohols. Let us consider ether. Okay, the question is, ether is more volatile than alcohol, okay, having the same molecular formula. Okay, for example, I'll consider ethanol, CH3, CH2, OH, ethanol, and dimethyl ether, CH3, OCH3. They have the same molecular formula, C2H6O, okay, C2H6O. What do you call this compounds as? Compounds having same molecular formula but different functional group. Here the functional group is OH, here the functional group is O. Compounds having same molecular formula but different functional group, they are called as functional isomers. They are called as what? Functional isomers. Are you able to understand? What are they called as? They are called as functional isomers. Compounds having same molecular formula but different functional groups are called as functional isomers. We will study this in organic chemistry. It is not the point of discussion now. Now the question is, ether is more volatile than alcohol. Why? Why ether is more volatile? See, observe here, okay, alcohol molecules, ROH, alcohol molecules, okay, they are held together by a strong hydrogen bond. Okay, there is hydrogen bond between oxygen and hydrogen. There is hydrogen bond between what? Oxygen and hydrogen. Okay, because of now hydrogen bond between oxygen and hydrogen. Okay, so alcohol molecules are held together by a strong hydrogen bond. Whereas in case of ethers, okay, there is no hydrogen bonding at all. In ethers, there is no hydrogen bonding. Okay, the only force of attraction is weak van der Waals force. What type? Weak van der Waals force. Here, alcohols have strong hydrogen bonding, whereas ethers have weak van der Waals force. We know. Okay, now volatility means that which can easily evaporate. Volatile means easily, okay, which can easily evaporate, okay, evaporate. So here ethers can easily evaporate but not alcohols. Ethers can easily evaporate but not alcohols. Why ethers can easily evaporate? Because the force of attraction among ethers will be weak. It's a weak van der Waals force. They have weak van der Waals force. Whereas the force of attraction between alcohols is a strong hydrogen bond. Okay, stronger the bond, lesser will be the volatility. Weaker the bond, more will be the volatility. Are you getting my point? So which one is more volatile? Ether is more volatile. Why ether is more volatile? Because there is no strong bond. There is a weak van der Waals force. Why alcohols are less volatile? Because of strong hydrogen bond. All the molecules, they are held together by strong hydrogen bond. They cannot evaporate easily. Okay, that is why ethers are more volatile, alcohols are less volatile, okay, for the same molecular formula. So what is the correct answer? Ether is more volatile than an alcohol having the same molecular formula. This is due to dipole character of ethers? No. Alcohols, where does alcohols have resonating structures? Alcohols do not have resonating structures. Is it because of intermolecular hydrogen bonding in ethers? I said yeah. Okay, there is hydrogen bonding in alcohols. What type of hydrogen bonding is it? Okay, the hydrogen bonding between two molecules. The hydrogen bonding between the molecules, it is called as intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Okay, the hydrogen bonding is present between the molecules. We call it as intermolecular hydrogen bonding. Okay, so there is intermolecular hydrogen bonding in alcohols, therefore they are less volatile, but there is no intermolecular hydrogen bonding in ethers, that is why they are more volatile. So the answer is okay, this is due to intermolecular hydrogen bonding in alcohols, not in ethers. Okay, intermolecular hydrogen bonding in alcohols but not in ethers. Okay, is that simple? That's great. Okay, yes students. Yeah, next question. Okay, which of the following when dissolved in water forms a solution which is non-conducting? Which of the following, okay, when dissolved in water forms a solution which is non-conducting? Non-conducting means it does not conduct electricity. Okay, it does not conduct electricity. When do you say that a substance conducts electricity? When do you say that a substance conducts electricity? Or what is the primary condition required to conduct electricity? Yes, the primary condition is there should be charged particles. Okay, there should be what? Charged particles. If the charged particles flow, they conduct electricity, isn't it? When the charged particles flow, they conduct electricity. Now, what is the primary condition to conduct electricity? It is charged particles. Charged particles may be free electrons. Charged particles may be free electrons, or else the charged particles may be ions, isn't it? Ions in the sense cations and anions. Cations and anions. Okay, the charged particles may be free electrons, or the charged particles may be ions. Ion in the sense cations and anions. So the question is, which of the following, when dissolved in water, forms a solution which is non-conducting? Non-conducting means there are no charged particles. If there are no charged particles, the solution is non-conducting, as simple as that, isn't it? If there are no charged particles, the solution is non-conducting. Now, okay, when dissolved in water, when you have to dissolve this substance in water. See, if I take more salt, okay, more salt. Student, what is more salt? More salt is ferrous ammonium sulfate solution. Ferrous ammonium sulfate. What is the formula for ferrous ammonium sulfate? Look at here. It is FeSO4 dot, okay, NH4 twice SO4 dot 6H2O. This is called as ferrous ammonium sulfate. Okay, so more salt means ferrous ammonium sulfate. What is the molecular formula for ferrous ammonium? So ferrous ammonium sulfate, FeSO4 dot NH4 twice SO4 dot 6H2O. Now, if you dissolve this substance, if you dissolve this salt, more salt, in water, what will happen? Well, it's a salt. It's a salt. We know any salt when dissolved in water will ionize. So it will ionize to give what? Ferrous ions, sulfate ions, okay, ammonium ions, okay, sulfate ions, correct? Okay, so when more salt is dissolved in water, it will dissociate into ions. Ions are charged particles. That means more salt solution has charged particles. If there are charged particles, then obviously this solution is conducting. Okay, if there are charged particles, the solution is obviously what? Conducting. Hence, this salt solution, more salt solution is conducting in water. It is conducting. Okay, correct. Next, if I take up rock salt. What is rock salt? Very simple. I hope you all knowing this. Okay, sodium chloride. Sodium chloride is called as rock salt. So what happens when rock salt is dissolved in water? It dissociates to give what? Na plus and Cl minus. So when rock salt is dissolved in water, it dissociates to give Na plus and Cl minus. So there are charged particles. If there are charged particles, the solution is conducting. Very simple. Now, what if ethanol is dissolved in water? What if ethanol is dissolved in water? Yes, this formula is C2H5OH. It's not a salt. Ethanol is not a salt. Okay, that means it will not dissociate in water. If it does not dissociate in water, there are no charged particles. There are no charged particles. Okay, so if there are no charged particles, the solution is what? Non-conducting. The solution is non-conducting. Am I correct? Yes, solution is non-conducting. Am I correct? Now, if I take potash alum, students, what do you mean by potash alum? Look at the molecular formula of potash alum. It is K2SO4 potassium sulfate dot Al2 SO4 thrice dot 24H2O. 24H2O. When potash alum is dissolved in water, what is it going to give? It will give potassium ions, sulfate ions, aluminium ions and sulfate ions. Look at here. This is giving charged particles when dissolved in water. Charged particles means the solution is conducting. So, more salt solution is conducting, rock salt solution is conducting, potash alum solution is also conducting, but ethanol solution is non-conducting because there are no charged particles, since ethanol will not undergo ionization in water. Hence, answer is option C. Option C. Simple. Okay, that's great. Yes. Next question. Okay, yes, we'll go with the next question. What is it? What is the shape of H3O plus ion? What is the shape of H3O plus ion? That is hydronium ion. So students, if you want to know the shape, okay, if you want to know the shape, you should know the hybridization. You should know the hybridization. Well, if you don't know the hybridization, then calculate the hybridization, students. That's it. Okay, if you know the hybridization, that's well and fine. You can clearly tell the shape. If you don't know the hybridization, calculate the hybridization and then predict its shape. Predict its shape. Okay, so shall we calculate the hybridization of hydronium ion? By the way, students, what is the formula for hybridization? Hybridization, okay, yes, is given by the formula half of V plus M minus C plus A. I have told you about this formula in the previous video. Hybridization is given by the formula half of V plus M minus C plus A. What is V? Number of valence electrons around the central atom. What is M? Number of monovalent atoms around the central atom. Okay. What is C? Total positive charge. What is A? Total negative charge. Okay. So yes, we have hydronium ion. Which is the central atom in hydronium ion? Yes, oxygen is the central atom. Isn't it? Oxygen is the central atom. Okay, so students, okay, look here, oxygen belongs to which family? Okay, oxygen belongs to which group? 16th group. Oxygen belongs to 16th group, isn't it? Okay, so if oxygen belongs to 16th group, the number of valence electrons in oxygen is 6. Okay, the number of valence electrons in oxygen is going to be 6. So what is the number of valence electrons? 6 plus, okay, now M means number of monovalent atoms. How many number of monovalent atoms? Yeah, hydrogen is monovalent, isn't it? Hydrogen is monovalent. So how many monovalent atoms are there? 3 monovalent atoms minus, what is the total positive charge? 1. What is the total negative charge? 0. Okay, 6 plus 3 is 9. 9 minus 1 is 8. Half of 8 is 4. Okay, so if you get the answer as 4, what type of hybridization is it? sp3 hybridization. sp3 hybridization. Students, just check. If you get the answer as 2, it is sp hybridization. If you get the answer as 3, yes, it is sp2 hybridization. Okay, yes, if you get the answer as 4, it is sp3 hybridization. For 5, it is sp3d hybridization. 6, sp3d2 hybridization. And for 7, okay, it is sp3d3 hybridization. Yes, so students, we are getting sp3 hybridization. Will it mean it is tetrahedral in shape? Is it tetrahedral in shape? Now, if I have to say it is tetrahedral, I just have to check whether it is regular geometry or irregular geometry. Only when it is regular geometry, yes, if it is sp3 hybridization, the shape of the molecule is going to be tetrahedral. Okay, if it is irregular geometry, okay, yes, with sp3 hybridization, the shape of the molecule is going to be what? Pyramidal. Okay, pyramidal. Okay, yes, are you able to understand? Okay, so now they have given hydronium ion, which we should just know whether it is regular geometry or irregular geometry. See, I told you, students, so oxygen belongs to 16th group. 16th group means 6 valence electrons. So out of 6 valence electrons, out of 6 valence electrons, oxygen has formed 3 bonds, okay, with hydrogen atoms, and the remaining 5 will be as what? Lone pair of electrons. Do you agree with my point? Okay, yes or no? Okay, so oxygen has 6 valence electrons. Out of 6 valence electrons, it has used 4 valence electrons to form bond with 3 hydrogen atoms. Therefore, there is one positive charge. That means 2 more valence electrons are lone pair of electrons. Hence, oxygen has both lone pair as well as bond pair. Oxygen has both. See, I'll tell you again. Okay, oxygen has 6 valence electrons, isn't it? 6 valence electrons. Out of 6 valence electrons, it has used 4 valence electrons to form bond with 3 hydrogen atoms. Okay, that means these 4 valence electrons are bond pairs, and the remaining 2 valence electrons are what? Lone pair. Is it correct? So that means oxygen has both bond pairs as well as lone pairs. So if oxygen has both bond pairs as well as lone pairs, what do you call that geometry as? It is called as irregular geometry. Irregular geometry with sp3 hybridization. What is the shape? Pyramidal shape. Pyramidal shape. Understood? So what is the correct answer for this? The correct answer is option B. Excellent. Okay, is that simple? What's the answer? It's not tetrahedral. It is tetrahedral only when it is regular geometry, but hydronium ion does not have regular geometry. It is irregular geometry. Hence, the shape of this molecule is going to be pyramidal. Pyramidal. Yes? Is that simple? That's great. Okay. Very nice. Okay, yes students. Next question. The magnitude of van der Waals force is maximum in. Okay, the magnitude of van der Waals force is maximum in hydrogen bromide, hydrogen iodide, hydrogen chloride and carbon dioxide. Okay, now which molecule has maximum van der Waals force? See, van der Waals force, okay, is directly proportional to what? Surface area. Okay, directly proportional to surface area. If surface area increases, van der Waals force increases. Okay, okay, if surface area increases, van der Waals force increases, and surface area is directly proportional to atomic size. Surface area is directly proportional to atomic size, and also surface area is inversely proportional to what? Branching. I'll teach you this. What is this branching when you take up organic chemistry? Okay, understand? So van der Waals force is directly proportional to surface area, but surface area is directly proportional to what? Atomic size. As the atomic size increases, surface area increases. As surface area increases, van der Waals force increases. They are, yes, they are interrelated. They are all interrelated. If the atomic size increases, surface area increases. If surface area increases, van der Waals force will increase. See, we have given with, okay, yeah, chloride, hydrogen is same, hydrogen. Okay, we have chloride, bromide and iodide. Okay, so we know as we go down the group, atomic size increases, isn't it? As we go down the group, atomic size increases. As the atomic size increases, surface area increases. As surface area increases, van der Waals force increases. So can I say that van der Waals force is maximum in case of hydrogen iodide? Yes or no? Van der Waals force is maximum in case of what? Hydrogen iodide. Hence the correct answer is option B. Then why didn't I consider carbon dioxide? See, carbon dioxide will have dipole force of interaction here. Carbon dioxide will have dipole force of interaction, but not van der Waals force. It will have dipole force of interaction. Okay, let us not consider this here. So van der Waals force, hydrogen bromide, hydrogen iodide, hydrogen chloride. Among them, which one has highest? It is iodine, because down the group atomic size increases. As the atomic size increases, surface area increases. As surface area increases, van der Waals force will also increase. Okay, is that simple? Yes. Next question, students. Okay, well, see, next question says, if the central atom in a molecule has 2 lone pairs and 3 bond pairs. Okay, if the central atom in a molecule has 2 lone pairs and 3 bond pairs, what is the shape of the molecule? Okay, 2 lone pairs and 3 bond pairs. 2 lone pairs and 3 bond pairs. 2 lone pairs and 3 bond pairs. Okay, 2 lone pairs and 3 bond pairs. Can you tell me what type of geometry? 2 lone pairs, 3 bond pairs. What type of geometry? Yes, it has both lone pairs as well as bond pairs. So what type of geometry is it? It is irregular geometry. Is it? It is nothing but what? Irregular geometry. Students, I will tell you one simple method, okay, to remember the different irregular geometries. Please remember this trick. I am going to write a table now. I am going to write a table. Okay, in one thing I will write bond pair, in one column bond pair, then lone pair, and then the geometry. Okay, yes, bond pair, lone pair, and geometry. Yes, please remember this. Please remember this. So look here how simple it is. 21, 22, 31, 32, yes, 41, 42, okay, 41, 42, okay, and then, yeah, that's it. Okay, 21, 22, 31, 32, 41, 42. Please remember this word beats, B-E-A-T-S, beats. Okay, just replace these two words by P, that's it. Only small modification. You remember the word beats, B-E-A-T-S, just replace these two words by what? P. Okay, yes. Look here, 21, 2 bond pair, 1 lone pair, 2 bond pair, 1 lone pair. Okay, the geometry is going to be bent shape, B. Okay, the geometry is going to be what? Bent shape. Okay, yes. Next, 2 bond pair, 2 lone pair. Again, the geometry is going to be bent shape, B. Okay, yes. Next, 3 bond pairs, 1 lone pair, 3 bond pairs and 1 lone pair, then it is pyramidal geometry. Okay, 3 bond pairs and 1 lone pair. Next, 3 bond pairs, so that is what I said. Okay, just replace these two words by P. After B, P. B, bent. After bent, it is P, pyramidal. Bent shape, pyramidal. Okay, 3 bond pairs and 2 lone pairs. 3 bond pairs and 2 lone pairs. This is called as T shape. Observe here. T shape. Is it correct? Okay. Next. Okay. 4 bond pairs, 1 lone pair. This is seesaw. Okay. Seesaw shape. 4 bond pairs, 2 lone pairs. Square planar. Okay, and lastly 5 1. Okay, 5 bond pairs, 1 lone pair, then it is called as square pyramidal. Okay, is that simple? Okay, we can also say phi 2, this is linear. Phi 1, phi 2, it is linear. Okay, at least remember till here. Phi 1, 2 1 bend shape, 2 2 bend shape, 3 1 pyramidal, 3 2 T shape, 4 1 seesaw, 4 2 square planar. Okay, phi 1 square pyramidal, phi 2 linear. So remember this words beats. Okay, B for bent, EA is replaced by P, P for pyramidal, T for T shape, C, S for seesaw, square planar, square pyramidal. Bent, bent, pyramidal, T shape, seesaw, square planar, square pyramidal, and phi 2 is linear. Phi 2 is linear. Hope you can remember this, okay, table. Now coming on to the question. Now when do you want to use this? Only if there is both lone pair as well as bond pair. That means we are talking about irregular geometry. Irregular geometry. So if the central atom has 2 lone pairs and 3 bond pairs, that means 3 2. Okay, 2 lone pairs and 3 bond pairs. 2 lone pairs and 3 bond pairs. So what is the shape? It is T shape. Very simple. Okay, 2 lone pairs and 3 bond pairs. Therefore the shape is what? T shape. Hence the correct answer is option A. Option A. Is that not? Yes. Okay. I hope it is clear. Okay. 2 1, 2 2, 3 1, 3 2, 4 1, 4 2, 5 1, 5 2. For 3 2 1 bend shape, 2 2 bend shape, 3 1 pyramidal, 3 2 T shape, 4 1 seesaw, 4 2 square planar, 5 1 square pyramidal, 5 2 linear. Okay, yes, beats, B-E-A-T-S, replace E-A with P. B means bent, pyramidal, T shape, seesaw, square planar, square pyramidal. Okay, for irregular geometry. Okay, yes. Next question. Yeah. Okay. Yes. Next question. Okay. See, please understand, this is quite common in most of the exams. Okay. See, if y-axis is the intermolecular axis, then pi bond is formed by the overlap of. Okay. If y-axis is the intermolecular axis, then pi bond is formed by the overlap of. See students, according to molecular orbital theory, we used to write the electronic configuration. Do you remember that? Okay. According to molecular orbital theory, okay, we used to write, okay, electronic configuration. Do you know the electronic configuration for elements for the substance or for the molecules with more than 14 electrons and for the molecules with less than 14 electrons? Yeah, any electronic configuration you can consider. For more than 14 electrons or for the less than 14 electrons. I will consider, okay, the electronic configuration for the molecules with more than 14 electrons. Okay, yes. I'll consider the electronic configuration for the molecules with more than 14 electrons. What was the electronic configuration? Look here, it is sigma 1s, sigma star 1s, correct? Sigma 2s, sigma star 2s. Now students, okay, then okay, 1s, 2s. After 1s and 2s, I have to go for 2p. 2p. See, in 2p we have 2px, 2py and 2pz, isn't it? Correct? Okay. So we have finished 1s, bonding, antibonding. 2s, bonding, antibonding. After 1s and 2s, I have to go for 2p orbital. For 2p orbital, we have 3, 2px, 2py, 2pz. See, among the 3 orbitals, if I consider one as intermolecular axis, let us say if I consider 2pz as intermolecular axis, then these 2 orbitals will form pi bond. This will form sigma bond. Okay. If I consider, it is arbitrary. It is arbitrary. If I consider 2pz orbital as intermolecular axis, then this is going to form sigma bond, whereas these 2 will form what? Pi bond. That is why we used to write, okay, sigma 2pz, okay, pi 2px, is equal to pi 2py, okay, then pi star 2px, okay, pi star 2py, okay, and lastly what? Yes, sigma star 2pz. Okay, that is what it means to say. See this, if 2pz orbital forms intermolecular axis, then the remaining two orbitals will form what? Pi bond. Okay, it is arbitrary, I said, you can choose anything. If I choose 2px as intermolecular axis, then these two orbitals will form pi bond. Observe here. So if I choose 2pz as intermolecular axis, then 2px and 2py will form pi bond. Okay. If I choose 2px as intermolecular axis, then y and 2pz will form pi bond. What if I choose 2px as intermolecular axis? Then, okay, 2px and 2pz will form the pi bond. So according to the question, okay, if y-axis is the intermolecular axis, then x-axis and z-axis will form pi bond, isn't it? Okay, so if y-axis is the intermolecular axis, then x-axis and z-axis will form what? Pi bond. Is that correct? So if y-axis is the intermolecular axis, then pi bond is formed by the overlap of 2px and 2pz. Yes or no? If y-axis form the intermolecular axis, then 2px and 2pz will form the pi bond. If x-axis forms the intermolecular axis, then 2py, 2pz will form the pi bond. If z-axis forms the intermolecular axis, then 2px and 2py form the pi bond. So what is the correct answer? So if y-axis is the intermolecular axis, then x-axis and z-axis will form the pi bond. So the answer is 2px and 2pz will form the pi bond. Okay. Next question. I'll go with the next question, students. Okay. Next question is like this. Which one of the following has the lowest boiling point? Okay. Which one of the following has the lowest boiling point? So we have hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. We discussed the same type previously also. Okay, which one of the following has lowest boiling point? See students, hydrogen fluoride molecules are held by hydrogen bond. We know this very well by now at least. Okay, after watching all my videos, I hope you might have come to a conclusion, or I hope you might have been thorough that hydrogen fluoride molecules are held together by what? Hydrogen bond, okay, is a strong bond, correct? Strong bond. Stronger the bond, higher will be the melting point and boiling point, because melting point or boiling point is directly proportional to what? The strength of the bond. Is directly proportional to the strength of the bond. Okay, stronger the bond, more will be the melting point and boiling point. Weaker the bond, lesser will be the melting point and the boiling point. So hydrogen fluoride molecules are held together by hydrogen bond. Hydrogen bond is a strong bond, therefore boiling point or melting point of hydrogen fluoride will be high. Is it correct? Yes. Okay, so hydrogen fluoride has high boiling point because the hydrogen bond is a strong bond. Okay, then how about hydrogen chloride, hydrogen bromide and hydrogen iodide? Well, these three molecules, they don't have hydrogen bonding. They'll have van der Waals force. They're held together by van der Waals force. Van der Waals force. Okay, we know that van der Waals force are directly proportional to atomic size, isn't it? Directly proportional to what? Atomic size. More the atomic size, more will be the van der Waals force. More the atomic size, more will be the van der Waals force. We have hydrogen, hydrogen, hydrogen. Okay. Then we have chlorine, bromine and iodine. We know down the group, atomic size increases. As the atomic size increases, van der Waals force will increase. That means, okay, hydrogen iodide, okay, has more van der Waals force than hydrogen bromide, which has more van der Waals force than hydrogen chloride. Okay, so hydrogen chloride has weakest van der Waals force. Okay, so if hydrogen chloride has weakest van der Waals force, okay, here the bond is weak, bond is weak, bond is weak. If the bond is weak, weaker the bond, okay, lesser will be the melting point and boiling point. Hence, the lowest boiling point is observed in case of what? Hydrogen chloride. Hydrogen chloride. Okay, so van der Waals force increases with atomic size. As the atomic size increases, the surface area increases. As the surface area increases, van der Waals force also increases. So hydrogen iodide has a strong van der Waals force than hydrogen bromide, than hydrogen chloride. So hydrogen chloride has weakest van der Waals force. That means it has least melting point or boiling point. Okay, hence the answer for this question is option B. Simple. Okay. Yes. Next question. Yes. Yes, let us go with this question, students. Okay. The molecule which has expanded octet above 8 electrons. Okay. Expanded octet configuration is the molecule which has expanded octet. They itself have given. What do you mean by expanded octet? Above 8 electrons. Above 8 electrons. So this is one of the limitations of octet rule, isn't it? Okay. Having more than 8 electrons. Limitations of octet rule. Having less number of 8 and less than 8 electrons. That is also limitations of octet rule. Having odd number of electrons. Limitations of octet rule. They are all the limitations of octet rule. That is, this is there in my video lectures. Please watch my video lectures. You will understand the limitations of octet rule. Okay. So students, the molecule in which the central atom has expanded octet, that means above 8 electrons. Above 8 electrons. So I'll consider water. Yeah. Okay. Water. See, we know the structure of water. H2O. Yes. So oxygen has 2 lone pair of electrons. We know this very well. Okay. H2O. Oxygen has 2 lone pair of electrons. Now, how many number of electron pairs around oxygen? Look. Okay. 1, 2, 2 electrons, 4 electrons. 1 bond means 2 electrons. So 2, 4, 5, 6, 7, 8. Oxygen has just 8 electrons. Correct. Oxygen is surrounded by 8 electrons. That means it has complete octet. It is stable. Okay. Yes. Not more than 8 electrons, not less than 8 electrons. It has exactly 8 electrons. Next, how about phosphorus pentachloride? Observe this phosphorus pentachloride PCl5. PCl5. Okay. Yes. So PCl5 structure is, okay, trigonal bipyramidal. Trigonal bipyramidal. This is the structure of phosphorus pentachloride. Trigonal, yeah, bipyramidal. Okay, this is the structure of phosphorus pentachloride. Just check how many number of electrons are there around phosphorus. Okay, one bond is equal to 2 electrons. 1, 2, 3, 4, okay, 5, 6, okay, then 7, 8, 9, 10. So altogether total, how many electrons are there around phosphorus? 10 electrons are there around phosphorus. That is more than 8 electrons. Isn't it? More than 8 electrons. If the electrons are more than 8, then we call it as what? Expanded octet. We call it as, what is that called as? It is called as expanded octet. Okay. Simple. Next, if you consider ammonia, what is the structure of ammonia? Pyramidal. It is like this. See this? Okay, it has two lone pair of electrons, one hydrogen, second hydrogen, and third hydrogen. Now, how many electrons are there around nitrogen? Yeah, 1, 2, okay, 3, 4, 5, 6, 7, 8. So nitrogen has 8 electrons. So complete octet. Octet is complete. Correct? Now, if you consider boron trifluoride, yeah, BF3. What is the structure of boron trifluoride? Trigonal planar. Trigonal planar. This is the structure. Okay. Yes. This is the structure of boron trifluoride. Now count the number of electrons around boron. 1, 2, 3, 4, 5, and 6. 6 electrons. It has only 6 electrons. That means less than 8 electrons. Less than 8 electrons, isn't it? So, which species has octet? No, expanded octet? It is phosphorus pentachloride, because it has 10 electrons, which is more than 8. So, expanded octet is observed in case of phosphorus pentachloride. Phosphorus pentachloride. Exactly correct. Yes. Okay, yeah. Next question, students. Choose, okay, the correct relationship among the following. They have given bond order, bond length, and bond energy. Okay, bond order, okay, bond length, and bond energy. Bond energy. See, it's very simple to understand, students. So if, okay, bond order, higher the bond order, if bond order is more, okay, bond length will be less. Okay, if bond order is more, bond length will be less. If bond length is less, bond energy will be more. Bond energy will be more. Are you getting it? So more the bond order, okay, more the bond order, lesser is the bond length. Lesser the bond length, more is the bond energy. More is the bond energy. For example, for single bond, double bond, triple bond, okay, single bond has, okay, what is the bond order of single bond? It is 1. Bond order is 1. Okay, for double bond, bond order is 2. For triple bond, bond order is 3. Okay, bond order is 3. Okay, as the number of bonds increases, as the multiplicity of the bonds increases, bond length decreases. As the bond length decreases, okay, we have to supply more energy to break the bond, isn't it? Okay, that means here, okay, single bond is longer than double bond is longer than triple bond is shortest, single bond is longest. Okay, so we have to supply more energy to break triple bond, then double bond, then single bond. Are you not able to understand here? Yes. So if the bond order is increasing, bond length is decreasing, is it? Bond length is decreasing. If the bond length decreases, okay, bond energy increases. That is what I mean to say here. Okay, yes, if bond order increases, bond length decreases. If bond length decreases, bond energy increases. So what is the relationship between these three? Can I say bond order is inversely proportional to bond length? Yes. So lesser the bond length, more will be the bond order. That's correct. Okay, yes. So can I say that bond order is directly proportional to bond energy? Yes. So where do we have the answer? Yeah, it is an option A. So bond energy is, bond order is inversely proportional to bond length, but bond order is directly proportional to what? Bond energy. Okay, yes. So students, I'll continue solving the problems in the next video also. Thank you.